These next few lessons that we're going to be taking a look at are going to deal with perfect and non-perfect squares. Now we're going to kind of look at the basics of it right now with perfect squares and what is a perfect square, and then we're going to take a look a little bit later at what happens if it's a non-perfect square and how do we solve that. But for right now, we're just going to say if it's a non-perfect square, we're not going to solve it for right now. We're just going to leave it off to the side. So let's first look at what is a perfect square. Now to start with here, a square is a shape which has 4 equal sides and each of the corners is 90 degrees. Now a 90-degree corner means that it is a perpendicular corner. So showing kind of with my hands there, it's perpendicular. You can see on this square here, that's a perpendicular corner and it's represented by, or it is 90 degrees. That's the angle that we have there. Now, another thing about a square is that each side is parallel to the opposite side. Okay, so you may have seen parallel lines in the past. It just means that these two lines here, they run completely in the same direction. They're never going to cross. They're never going to get closer to each other, never going to get farther away from each other. They're always going to run perfectly straight, and so they're perfectly parallel to each other. Finding the area of the square is based on the length of the sides. Now we're going to get into this in a few more lessons, so it'll be a few weeks here before we get to this, but we're going to start looking at how to find area. And you might have seen this in the past, but the area of a square is represented by length times width. Now this isn't necessarily a square, this is actually also a rectangle, and a square is a rectangle. Okay, that's an important thing to understand. We'll go through that later on. If you're not sure about it, you can talk to me in class, but for right now, we're just going to understand that we're using the rectangle formula, area equals length times width, and we're going to call this the length. We can also just give it a little L, and this is going to be the width, and we're going to call that W. Now, I use a stylized L, as a regular L looks a little bit more like a 1, and so I use a stylized L or a cursive L, so we can think of it in that way there. Okay. Now, in a square, we know that, again, we have these perpendicular corners, okay, 90 degrees, and we can represent those by little squares here, okay? And we know that all these sides are exactly the same length, okay? And I'm just going to draw it out with a little, little notch or tick, if you want to call it. And so if there's one tick here and one tick there, or one line and one line, that means that these two are the same length, okay? We can represent that. If these both had one line and these both had 2 lines, that would mean that these were the same length and these were the same length. Okay, so it's something that we can think about when we're looking at lengths, and we might see that represented later on. If there's no little tick marks, then we don't know for sure, but because this is a square, we understand that these are in fact all the same length. Okay, we don't necessarily have to always write those tick marks in there. Now, as the length and the width of the square are the same, okay, we can rewrite our area thing. So we can also say that this is the length right here too. And I'm just going to put a little L there. Okay, length and width are exactly the same there, so we can do length times length, or we can write length squared. Just means length times length. The squared, you've seen a little bit of exponents in the past there. We're going to get more into exponents as we go as well, but for right now, length squared just means length times length. Okay, so that's looking at finding the area of a square. Now, when we talk about a perfect square, and this is where we're kind of getting to our lesson is on perfect squares. A perfect square is one which has a side length which is a natural number. Okay, it's a natural number, so things like 1, 2, 3, 4, 5, and so on and so forth. A natural number is one that, there, again, no decimals, no negatives, no zero. Those are natural numbers. Okay. The area of these squares is referred to as a perfect square. So whatever the area that we get of this square, which has natural number sides, okay, now again, remember the natural number is going to be exactly the same. So if this side is 1, this side is 1, okay? And the area is going to be those two sides multiplied together. Now that area is represented as a perfect square, okay? So it's represented as a perfect square. Now, a perfect square is a number which can be described by a multiplication statement that involves the same number, and again, perfect square is going to be a natural number, twice. Okay, so same number twice. So let's look at a couple examples here. The first one, 1 times 1. So if we have a length of 1 and a width of 1, or both sides are 1, 1 times 1 is 1. Therefore, our answer of 1 is a perfect square. So 1 is a perfect square. Okay, and that's important to recognize. 2 times 2, so if we use, again, the same number, it's a natural number, multiply it together, 4 is also a perfect square. And we have a whole bunch more. There are, well, technically an infinite number of perfect squares. We're not going to deal with an infinite number. We're going to take a look at the first 20 for the most part. And I'm going to be expecting that you memorize the first 20 so that we understand that. The first number aren't too difficult. It's those, it's the ones that kind of get from 10 through 20. Those ones are a little bit of a challenge. But I will get you to start writing them down and to use them and to memorize them as well. Okay, so something like 2 times 2 is 4. 4 is a perfect square. Our next one, and this is part of your assignment, is 3 times 3, which is 9. So 9 is a perfect square. I want you to take a look at questions 1 and 2, dealing with perfect squares. Question 1 asks you to find the first 10 perfect squares. So 1 would be the first one, 4 is the second one, 9 is the third one. You'll notice 1, 2, 3. Okay, so I want you to find the first 10, and then after that, question number 2 is asking for the next 10, so from 11 to 20, to look for those perfect squares as well. And the first 10 will be from 1 to 100, and the second 10 will be from 101 to 400. Will be in between there. So I want you to work on questions 1 and 2 from the assignment. It's looking at what are our first 20 perfect squares.